So we're working in OpenStax Statistics, Chapter 8. We're going to talk about the example of confidence intervals with statistics exam scores. So you can always reference the OpenStax text for free. Just look in the description of this video and you can get a link to the book. And then the Excel workbook that you see here, you can also access that for free. Just go to divideandconquermath.com and go to the OpenStax Statistics section. Okay, so this is an example that's already been worked out, just so you can kind of see a way to set up everything. So the example here is, suppose scores on exams and statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. So a random sample of 36 scores is taken and gives a sample mean of 68. And so we're going to find a confidence interval estimate for the population mean score. Specifically, we want to find a 90% confidence interval for the true population mean of statistics exam scores. Okay, so first things first, whenever you read a problem like this, you want to just kind of take out the given data, and you just want to make sure that you're paying attention to how you're thinking about it. So we're told here that we have a sample of 36 scores, so that's an N of 36, and that sample of 36 has a mean of 68. Now, the weird thing about this particular problem is that in the first line, we're told what our standard deviation is, but I want you to pay attention to what the key word is here. The key word here is population standard deviation. And so this is kind of a more theoretical thing that exists more in statistics books and doesn't usually exist in real life, but this is something that you practice really in any statistics class. So in this case, I have the population standard deviation, and you always just want to get in the habit of, when you find that standard deviation in the back of your mind, you just want to always think, are we talking about sigma or are we talking about S? And this will matter more as we move through other tabs. So since it's population standard deviation, we have sigma. Okay, so that's our given data. And then we need to figure out, so when we're building this confidence interval, like what are we building it around? And so the idea behind this is, so you are told to find a 90% confidence interval. So from that, you can find your alpha. So alpha is found by taking 1 minus the 90%, which comes out to 0.1. Okay, now when we're talking about confidence intervals specifically, so we always go with this procedure. Now what you do with your alpha will change depending on the context, but in the context of confidence intervals, so we identify our alpha, and so then what we're going to do is we're going to find the critical value associated with half of this. So for the critical value, I have the formula in here for you to reference it. So basically what we're trying to do at this point is, so let's see, I'll just maybe draw like a quick little picture here just so we can kind of visualize it. Okay, so this is not my best drawing, I'll admit. But okay, so I've got my normal curve. So the idea here is that I'm taking my alpha. So this is going to be my 0.1 divided by 2. So that's going to be 0.05. So the idea is I take that alpha and I split up basically the 10% of the area split between the two tails. So this is what we think of as our alpha, okay? And so when I try to find the critical value, I am trying to find what is, so, and this is, by the way, this is the standard normal distribution. So I want to know, what is this z-score down here? So this critical value, it's technically a z-score, and it corresponds with the area that has been split between these two parts from your alpha. So notice how I set up my critical value. I use my NORM.S.INV, which will give me a z-score, but I take that alpha value and see how I've divided it by 2. So that's what's going to help me figure it out on each side. Now, remember that the NORM.S.INV function, this always returns a negative value. So all of our normal distribution Excel functions, they always return the leftmost value, something to the left. But when we're talking about confidence intervals, we typically want this to be positive. And then what I've noticed that your book does, so I don't always do this when I'm doing my own calculations, but your book tends to like to round to 3 decimal places. So one thing you could do if you want to match what the book typically does is, one, you can take the absolute value. So you see I have ABS of this value here, so that just makes everything positive. But you'll also notice I used a rounding function here, and I asked this to round to 3 decimal spots. And so this will match now what the book has. So that part's kind of optional. I usually just take the positive version of this number here and run with it. But if you want things to match, you usually have to round a little. Okay, so that being said, so from here, so once you have this information, so just notice what we've done. We've got our given data. We found our alpha. We calculated a critical value. Now we have all the information we need to really finish this. So the next thing I like to do is I like to calculate the error bound, so our EBM. So I have the formula written out here just so you can follow it. So you take that critical value. So notice how this is labeled, z sub alpha over 2. So I told you this was a z-score, and I told you that we take this alpha value and we divide it by 2. So that's literally what this is here. So I take this value here times whatever my sigma divided by the square root of n is. And so that's what I plug in here. So I've got my critical value times sigma divided by the square root of n. So I've just referenced all of that in the formula. And from here now we're really done because what we're going to do is we're going to compute the confidence interval. So the confidence interval at the end of the day, so it is this like big looking formula, but I want you just to notice, okay, this is z sub alpha. This is not labeled correct in the book, but I just took the formula from the book anyways. So this is the critical value times sigma over the square root of n. This is your error bound, okay? So notice what's happening here. I have x bar plus the error bound and x bar minus the error bound. So that's really why we want to calculate the error bound separately, because then it's just adding or subtracting that error bound. And so notice how I've actually set this up. So I have this set up then as I take for my high value, my mean plus my error bound. And then for my low value, I take my mean minus my error bound. And I just noticed I have a little mistake here, so I'll make sure I correct this in the actual Excel worksheet. But the final confidence interval would be you take the low value and then you take the high value, and that's going to be your confidence interval. So what you see here. And so that's how you kind of organize everything, and that's how you do everything. And so now we're going to practice that more in the next spreadsheets in the next videos.